Today we are going to talk about solving real-world applications with inequalities. So you should have this piece of paper in front of you, and we're going to go through the following problems. So as you can see by the definition or by the instructions, we're going to define a variable. We're going to write out an inequality represented by the situation, and we're going to solve for the inequality that is missing. And obviously we're going to show our work. So let's look at the first problem. Mason wanted to make a dance crew. Each dance crew can only have up to, and I'm going to underline that because that seems important, up to 8 members per competition rules. How many dancers can join him? Okay. So based on what we've learned before with real-world applications, the question helps us with the variable. So how many dancers can join him? So we're trying to figure out the number of dancers that he can have join him. So we want a variable that matches it. Now you can pick X or you can pick a letter that represents what you're looking for. We're looking for dancers, so I'm going to go ahead and say D. So D is going to be the number of dancers that can join Mason. Oops. Now we need to create an inequality that represents the situation. So we know that there's going to be a number of dancers that can join Mason. And we know that we can have up to 8 members. So if we look back at our words and phrases that we learned in lesson 4.1, okay, we don't have the phrase up to, okay, but we have phrases that are similar to it, like at most or maximum, no more than. So this up to is going to be using a less than or equal symbol. Okay, so less than or equal to 8. Okay, however, my answer is not just going to be D is less than or 8 because the dancers are joining Mason. Mason wants to be a part of this dance crew. So we need to include Mason. So therefore, this is going to be D plus 1 because Mason's involved. How many can join him? So this would be the inequality that represents our situation. Now we're going to solve. Okay, this is where we have to show our work. So we're going to rewrite the inequality that we just wrote down, and we're going to show our work to solve. So we're going to subtract 1 from both sides. And we get D is less than or equal to 7. Now, our final step is to state your final answer. And every time you're doing application problems, you want to make sure you include your units on your final answer. So we're not just going to say D is less than or 7, less than or equal to 7. We're going to incorporate what does D mean. So D is the number of dancers that can join Mason. So another way of saying this would be that Mason can have up to 7 dancers joining him. Okay, you could also say that Mason can have at most 7 dancers joining him or a maximum of 7 dancers joining him. Okay, so it only says up to 8, which means that he could have 7, 6, 5, 4, 3, 2, 1, or no one join him. But at most or up to 7 dancers can join him. And this is how we would solve number 1. So these are our 4 steps we're going to follow. Right, next problem we have is Maria's rent is $870 a month. If she gets paid $7.25 an hour, what's the minimum number of hours she needs to work to pay for her rent? So we are trying to figure out the number of hours that she is working. So I'm going to say H is the number of hours Maria works. Okay. Now we want to think about what is an inequality that would represent the situation. So we want to incorporate the $7.25 an hour, the $870 that she needs to pay, and considering it's a minimum number of hours. So go ahead and write down what the inequality is that you think it should be and come back and check. Okay, so if we can incorporate how much she makes an hour, that would be 7.25 per hour. And this is a minimum number of hours to be able to pay $870 a month. So if we look back at those phrases that we learned in unit or lesson 1, minimum means greater than or equal. So the number of hours actually needs to be greater than or equal to 870. Okay, because we want her to have more money than she needs to pay for rent. So this needs to be greater than or equal. So what's the minimum number of hours she can make to pay that bill? So then we bring that equation down here. And we solve. So we're going to divide by 7.25 on both sides. Use our calculator. And we get H is greater than or equal to 120. Okay. Now go ahead and write down what you think the final answer could be worded as and come back and check what it could be. All right, so one way you could state your final answer is that Maria must work a minimum of 120 hours. Okay, now to clarify, this is not 120 hours a week. This would be in a month. Okay. Which 120 hours in a month is not too many. Okay, that's really only like 3 weeks of full time. Okay, but now in reality, does she need to work a lot more than that? Yes, because she needs to pay for utilities, food, and everything else. But based on this question, it just asks what is the minimum numbers to just pay her rent. So she has to work 120 hours just to pay her rent. Let's go ahead and look at number 3. Okay, number 3, Michael is working on a paper. If he must write less than 500 words, or he will have points deducted, and he has already written 384 words, how many more words is he allowed to add? Okay, so we're considering what he is doing. So it's writing a paper, and we want to know how many more words he's allowed to add. So I'm going to say W is the number of words Michael can add. Now we want to go ahead and set up your inequality, solve your inequality, and show your work. And I just realized this, for some reason, got re-listed as this. I will fix that for your print, for your copy. Go ahead and write your inequality. From here. So we know that he has already written 384 words, and we know this is the amount of words he can add. The question is, we want it to be less than 500. So this one is just pretty straightforward, a less than 500. So sometimes it's at most 500, but this one actually says less than 500. Now I know some students might say, oh, well, can't I just put 499? Well, you need to use the numbers that are given to you in the problem. So less than 500 would be the correct way of going about this. All right. Go ahead and solve this and state your final answer and come back to see if your answer is correct. All right, let's check your work. So 384 plus W is less than 500. So we're going to subtract 384 from both sides. So W is less than 116. So one way of stating your final answer is that Michael can write less than 116 words. Okay. Okay. Michael can write less than 116 words. And similar to what I said earlier, we would not want to change this answer and say Michael could write at most 115 words. You always want to use the number that you have solved in the problem. And using phrases from the problem itself is helpful as well. So less than is written here. So using less than here also helps. All right. Let's go ahead and read number 4. Okay. Z has at most $70 to spend on clothes. He wants to buy a pair of jeans for $22 and spend the rest on t-shirts. Each shirt costs $8. What is the maximum number of shirts he can purchase? So go ahead and go through parts A through D all on your own and come back to see how you did. Okay. So if we're going to identify our variables, first thing I'm going to look at is that he has at most $70 and he's buying $22 jeans and the rest on multiple shirts that cost $8. So we have 3 different numbers going on here. But we want to know what is the maximum number of shirts he can purchase. Now, in this question, we have 2 different phrases. We have at most and maximum. And both of those are listed under the category of less than or equal. So let's get that variable set up so that we can then set up our inequality. So we want to know about the shirts. So I'm going to say S is the number of shirts that Z can buy. Okay, so let's incorporate what we know. So we know that he's getting a $22 pair of jeans. And he wants to get multiple $8 shirts. So we're going to add 8S. And then we know that at most and maximum mean less than or equal. So less than or equal to $70. So he can spend at most $70, but he also could spend less than. He just can't spend more than $70. Now we're going to bring down our inequality here. And we're going to solve. So the first thing we're going to do is subtract $22 from both sides, or 22. So I get 8S is less than or equal to 48. Then I'm going to divide by 8 on both sides. And S is less than or equal to 6. So an acceptable answer is that Z can buy at most 6 shirts. Okay, you also could say Z can buy maximum of 6 shirts. Both those phrases would work. Okay. Right. That concludes our notes on real-world applications using inequalities. Good luck on your assignment. Ask questions when necessary.